Hello and welcome to lesson 5.1. We're talking about angles in a triangle today. So your main goal is can you find missing angles in triangles and missing sides? And also you're going to be able to order sides from greatest to least or tell if it can even make a triangle. So we're going to start with something you probably already know. The sum of the measures of the three angles in a triangle has to be 180 degrees. Okay, so that one's pretty obvious. I think most of you have used that before. So we're going to find the missing angle in this triangle. So to do that, we would have to do 37 plus 68, which gives us 105 degrees. And so two of the angles add to 105. To find the third one, the total of the triangle has to be 180. Subtract the other two angles will leave us with 75 degrees for x. So we get 75. So the main concept we're using is that the angles in a triangle have to add to 180 degrees. The next example looks at two triangles, and this goes back to, do you know what these symbols mean? So I want you to pause the video and see if you can find what x, y, and z are, and then come back and check your answers. All right, I hope you looked at this angle 43 right here and said that's the same congruence marking as x. So x has to be 43 degrees. And then hope you looked at 87. And if x is 43, we can find y by adding the angles up. Whoops. 43 plus 87, and then subtracting from 180. So we get 130 for those two angles. So 180 minus 130 leaves y to be 50 degrees. And if you look over here, the other angle in this small triangle has to be 87 because it has the same congruence marking as that angle. So that must mean z also equals 50 degrees. Again, just practicing using the fact that a triangle adds to 180 degrees. All right, I want you to look at this example now. Pause the video and see if you can find x and y. Using the same property we just used, triangles have to add to 180 degrees. All right, go ahead and check your answers. I hope you looked at and saw that x was easy to find. You did 35 plus 65, which gives you 100. Right, and then 180 minus 100 leaves us with 80 degrees for x. And one thing we've already talked about in chapter 2 was this angle and this angle are vertical angles, so they're congruent. So if x equals 80, this angle has to equal 80. And that then allows us to find y. So even though it didn't ask us to find this angle, we have to. So 43 plus 80 gives 123, so 180 minus 123 leaves us with y. So y is going to equal 57 degrees. All right, so I hope you got this down. We're going to move on to another example using, again, some other angle properties that we learned in chapter 2. So pause the video, see if you can find x. Y should be pretty straightforward. All right, hope you found an answer. Y should have been adding the two other angles together. 36 plus 65 gives us 101. And then 180 minus 101 leaves y to be 79 degrees. All right, and we cannot find x yet. Oops. Because we don't know what this angle is right here. And once we find that angle, we can find x. So think back to chapter 2. Anything that fell on a line was called a linear pair, and they also added to 180. So this angle has to be 101 because y is 79. And now we know two angles of this triangle right here. This triangle. Okay, we know two angles, 101 and 15. So 101 plus 15 gives me 116. So whatever's left over is going to be x. So 180 minus 116 leaves me with 64 degrees for x. Okay. All right, now we're going to move on to properties of isosceles triangles and equilateral triangles. So this says if a triangle is isosceles, then its base angles are congruent. So in other words, oh, I'll just make a triangle. I'm not very good at drawing on this quite yet, so let's erase this. Right, and then I'll go up to my tool up here and make one. So if we have an isosceles triangle here, meaning that two of its sides are congruent, means I have this side congruent to this side. That means that these two base angles, this is called the base angle because it's where the two congruent sides meet at a base. So this bottom segment here is called the base. And so the angles off of it are called the base angles. So if the two sides are congruent, then the two base angles are congruent. And the same is true if we know the two angles are congruent, then we know it's an isosceles triangle. So if I copy that triangle over, right, so if I start with the same triangle, and if I know that the base angles are congruent, that tells me that this must be an isosceles triangle. So these two sides must be congruent, right? One more property is an equilateral triangle is also what we call equal angular, which means all the angles are equal. So let me just write that up there. All angles equal, okay? And if it's an equal angular triangle, that must mean it's equilateral. And we know that an equilateral triangle then is all sides are equal. So if I create a triangle, see if I can make it. If I have an equilateral triangle, meaning all sides are equal, that also implies that all the angles are equal. And we know that in an equilateral triangle, all the angles are 60 degrees, right? So now we're going to do a couple examples involving isosceles triangles. So we only know one angle in this picture, so we can't use the property quite yet that they add to 180. But we do know something special, that these two angles are congruent, this angle and this angle. They're the base angles. So we know right now that y equals 70 degrees. And once we get two angles, we add them together and get 140. 180 subtract 140 leaves us with 40 degrees left over for y, or for x, excuse me. Okay. So the fact that it's isosceles really gives us a lot of information about this triangle. So here's a second example. I want you to pause the video and see if you can figure out what x and y are. All right, hope you got an answer. We know, since it's isosceles, that this angle is congruent to, excuse my writing, this angle. So one of the angles is 36. So let's subtract that from our 180 degrees right away. So 180 minus 36 leaves me with a possibility of the other two angles having to add to 144 degrees. Well, since we know they're equal, we have to divide that 144 degrees into two angles. So we're divided by 2. That means each angle has to equal 72 degrees. So again, the fact that it's isosceles really helps us know that we can find those two angles. Right? The last example we're going to do involves doing some algebra, so think back to your solving skills. Right? So looking at this triangle, I know 2 out of the 3 angles, and I also know this exterior angle is 84 degrees. Right? So I can easily find this angle right here because they lie on a line, so they're called a linear pair. So 180 minus 84 leaves us with 96 degrees. So this is 96, right? All right, so an equation magically appeared down there, and I'll explain to you what it means. If we know the 3 angles in a triangle, we know that it has to add to 180. So that's why we have it equal to 180. And our first angle is 12x, so I did 12x. Second angle is 16x plus 28, so I did 16x plus 28. And we found our third angle to be 96, so we add it all together and it equals 180. And now is when we need our solving skills. So we combine our like terms, 12x and, oops, I forgot my x here, and 16x give me 28x. Okay. And then 28 plus 96 are my other two like terms, and that gives me 124. Right, now it's a two-step, so you minus 120, subtract 124 from each side, 28x equals 56. Divide both sides by 28. X is going to equal 2. Right. Now we're going to move on to some pictures, and I want you to tell me for each picture if it can create a triangle. So think about it in your head, look at this picture, can it create a triangle? And I'm guessing this is the picture that popped into your head. It will not because the ends will not meet. So if we look at the two shorter sides here, 5 and 4, they're not long enough to even make a 10 centimeter segment, so they will not connect when we go to try and form our triangle. Right, now I want you to look at this one. Will a 10 centimeter and two 5 centimeter sides make a triangle? If you think about it, half of 10 is 5. So one of the segments will be right there, and the other segment will be right there. And so the issue is it doesn't create a triangle, it actually creates a straight line. Right? So then this last one, I want you to think, will this create a triangle? You look at your two shorter sides, we got a 7 and an 8 centimeter side. And then our biggest one is 10. And so I'm hoping you think, oh, 7 plus 8 is 15. That's got to be bigger than my other side. So they will touch. They'll look similar to this. Right? So if we look back at the first one, the two sides added together, the short ones, were smaller than the biggest one. This one, it was equal and it didn't create a triangle. But finally, once we got it to be bigger than the third side, it created a triangle. So that's called the triangle inequality. What it says is any side of a triangle is always shorter than the sum of the other two sides. So what I do is I take my two shorter sides, and that has to be bigger than the longest in order to create a triangle. Okay. And then we're going to look at ordering triangles. Okay. If we know the sides, we also know something about the size of the angles. All right. So if we look at ordering these angles or arranging these angles from greatest to least, I want you to just pause the video and see if what you would think when you look at this. What would be the biggest angle and what would be the smallest? Right? And this is the order I come up with. Z, X, Y. And let me explain why I got that. The biggest angle is always going to be across from the biggest side. So if I look at the biggest side is 5 centimeters, Z is across from the 5 centimeters, and the smallest angle will always be across from the smallest side. So I know Y is the smallest. Therefore, X must fall right in the middle because its side is the middle side. And the same can be true if you know the angles. You can figure out information about the sides. So I want you to pause the video and see if you can arrange these side lengths from greatest to least. All right, so my first step would be to find that third angle. So I get 55 plus 35, 90, 180 minus 90 will leave me with 90 degrees for this one. So the biggest side has to be across from the biggest angle. So C is the biggest. The next biggest angle is 55, so A is in the middle, and the smallest is across from the smallest angle. So I get B as my last side. And this is another property, it's the triangle angle side relationships. So basically what I just said, the shortest side is always opposite the smallest interior angle, and the longest side is always opposite the largest interior angle. So if we look at this, the shortest side is across from 35 degrees because it's the smallest angle, and the longest side is across from 90 degrees because it's the biggest angle. Right, and in order to complete the last couple problems in your homework, you need to know one last property about an isosceles triangle. So if I create an isosceles triangle here, right, so there's my isosceles triangle. So far we know that isosceles means two sides are congruent and its base angles are congruent. Right, now it says if I draw an altitude in, so I'm going to draw an altitude in, and remember back to chapter 3, an altitude is perpendicular to the base from the opposite vertex. So this is now a right angle. That's my altitude. And for an isosceles triangle specifically, the altitude will also be the median. So if you think back to last two chapters ago, the median divided went to the midpoint of the other side, so the midpoint divides that into 2 equal parts. And it's also the angle bisector, so remember bisect means divide in half, so these 2 angles up here are going to also be congruent. Okay, so the key point is the altitude, median, and angle bisector are all the same thing in an isosceles. So looking at this picture, I know a lot of information just from a couple things, just because it's isosceles. So we're going to go through this example. Pause the video and see if you can figure out BC, AD, and DC before we go ahead and do it. All right, so one key thing you know you're going to need to use is that the perimeter is 60 centimeters. So what I do when I go across this problem is I label what I know. So I know that this is 22 centimeters because it tells me it's given. And because it's isosceles, I also know this one is 22. So using the perimeter, my total perimeter has to be 60. Well, 2 of the sides add to 44, so if I subtract it from 60, I'll get what's left over, which is 16. So this bottom side has to be 16. And so BC is 22, I already filled that in. And this bottom side AC is 16. And think back to that property we just talked about. The altitude is also the median and the angle bisector. So I know these 2 sides are congruent. So AD and DC will have to equal 8 each. Right, and we're going to use that property again in this problem, except now we're going to be looking at angles. So measure of angle CAB is 55 degrees. Right, so I filled in everything I know. Pause the video and see if you can figure out the rest, just using that property that the altitude is the same as the median and the angle bisector. Right, so it looks like we have the median here. But we also know that it must be a right angle and that these 2 angles up here are congruent based on that property we just looked at. We know that CBD or CBA is also 55 degrees because it's isosceles, base angles are congruent. So CBD is 55 degrees. And let's look at, we can figure out what ACB is right here, this big angle, because triangle has to add to 180 degrees. So 55 plus 55, that's a 5, is 110. So that must leave me with 70 degrees for this one. And CDA, this angle down here, since we know it's an altitude, that has to be 90 degrees. And lastly, ACD, since it's the altitude, the median, and the angle bisector, it cuts this top angle in half of 70 degrees. So 70 divided 2 will give me that final angle, which is 35 degrees. So we learned a few properties today. Your homework will be page 93 through 95, 1 through 9. I hope this helps.